Good morning. Today we are continuing on with those triangles and angles. We are working on Po55. I can solve for the unknown angle in a triangle or a quadrilateral. So to do this, first thing we have to remember are how much or what degree measurement all triangles will always equal to. What is our magic number of any? 180 degrees. So every time we add up those three angles, it will always be 180 degrees. Now, a quadrilateral is a four-sided figure. So every three-sided figure is a triangle. Every four-sided figure is called a quadrilateral. No matter what that four-sided figure looks like, could be a square, could be a rectangle, a diamond, no matter what. We can always break that quadrilateral into two triangles. Always. Quadrilateral can always be split in half into two triangles. So how many degrees would those four angles equal to be? Avery? If a triangle is 180 degrees, if we add up all four angles of a quadrilateral, think it through. One triangle is 180 degrees. One triangle is 180 degrees. What would a quadrilateral have to be? Jack?
You'd have to add up 180 and 180.
And that would be what?
Oh, I got it. That would be 360.
A quadrilateral will always have all four angles equal to be 360 degrees. Because it's two triangles. One triangle is always 180 degrees. So two triangles would always be 360 degrees. Michael?
So if you have two protractors, then that would be 260 degrees.
Correct. So why is this important? Because if you know how many degrees are supposed to be in a shape, you can easily set up an equation to solve for an unknown angle. So let's take a look at what that means. So 180 is important to remember for triangles, 360 for that quadrilateral. So if I know that one angle is 70 degrees, one angle is 60 degrees, how can I find my missing angle? Any guesses? What should I do, Moses? So Moses said add 60 and 70 together. That gives us 130. So we know we have 130 degrees. We're going to subtract that from our 180 degrees. What is left is our 50 degrees. That is one way we can do it. Another way, we could say that total of 180 degrees minus 70 degrees and then minus that 60 degrees. 180 minus 70 is 110. 110 minus the 60 gets us that same 50 degrees. So it's whichever way you're comfortable working with those numbers. Do you want to add the ones together that you have and then subtract it from that total? Or do you just want to take the total of 180 and subtract out all the ones that you have? You get the same answer either way. Let's look at our quadrilateral. How should we find that missing angle? What would you do, Michael? So Michael says add 120 plus 75 plus 85, and we get we get what? We add all three of those together. Get your calculators out. Rhoda?
280.
Then we take that 360, because remember it's a quadrilateral, it's two triangles. So 360 minus 280, and we get 80 degrees. We could also have started with that 360 and subtract out those three angles. 360 minus 120 is 240. Minus that 75 would be 165. Minus our 85. And that brings us down to that same 80. So you can start with the big number and just subtract them all out. Or you can add together the angles that you know and then subtract them out. Either way works. We get the same answer. So, let me scroll up. In each figure below, we're going to solve for the unknown angle. And you have to show your work. So you have to write down which way you're doing it. Okay, you don't have to go through, okay, 180 minus 40 is 100. You don't have to go through it like that because we can use calculators in 6th grade. But I do want you to write out what you're putting into your calculator. If you're adding the two together, you would put 40 plus 35 equals 75, and then 180 minus 75 equals what? Who thinks so? Avery? 105. Circle your final answer. Put the degrees on it. Okay? So you do have to show your work. You don't have to do all of the work by hand. You can use the calculator, but show me what calculations you're putting into the calculator. Does that make sense? If it is a triangle, you're going to use 180 degrees. If it is a quadrilateral, what is our magic number? Joy? 360. So if I look at this one, I can subtract all three of those angles from 360 to find our missing angle. I want to point out some specialty things. Look at this one. How would I solve this, Moses? We're going to have to use our previous knowledge. We know that this box means it's a right angle, and we know right angles are 90 degrees. So I can figure out that missing one, right? Fill in those angles that aren't obvious, right? There's a box there. I have to know that that box means it's a right angle, and that means it's 90 degrees. Then I can do my same work. Let's look at our second page. This one, this triangle doesn't even have any numbers. Oh my word. How am I supposed to figure this out? There's no numbers. Vinny,
They put 60 on every side
how do I know it would be 60, Vinny?
because they're all even and then all them together.
How do you know that they're all congruent, Vinny? What on that triangle tells you that those sides are congruent? Say that again.
Like the lines.
These little hashtag lines, the little hash marks, right? There's 3 of them. That means that all 3 sides are congruent. If there's only 2, 2 sides are congruent. But because there's 3, I know they're all congruent, which means it's an equilateral triangle. And remember what we talked about in the last objective. Equilateral triangles are also equiangular, and then remembers equiangular triangles all equal 60 degrees. 60 plus 60 plus 60 is 180. Let's look at our next one. How am I going to figure that one out? I see 4 angles, but only 2 measurements, 100 degrees and 100 degrees, and then I see 2 arches. What does that tell me? Rhoda?
That they're 90 degrees.
When have you seen me use this? I have used it. What do I say that means, Alex?
If it's a cube,
Well, doesn't mean it's acute. Joy? It means they're congruent. Just like on the sides, we do the line to show they're congruent. For angles, we do the arch. There's one arch and there's one arch. That means those 2 angles are congruent. So how do we, okay, so we know they're congruent. We know 100 degrees and 100 degrees. We know our magic number is what? Claire? 360. So I'm going to take away the 2 that I know. 360 minus 100 minus 100. So that gives me 260, 160. So I have 160 degrees left. And I have 2 congruent angles. That means they have to be the same. What should I do? What do you think, Haley? Take a guess.
not 160 on each side.
So 160 has to be split up amongst those 2 angles.
So you divide 160
Why would I divide it by 2? Because they're even numbers. So 160 divided by 2. Because I have 2 angles that are the same, they are congruent. Do you guys see how we figured that out? Taking what we know from the past and using it to solve it. So both of those angles have to be the same measurement. Let's look at our next triangle. I want to find inside angles of the triangle. I know this angle is 75 degrees. This angle, I have no idea. This angle is right next to one that says 140 degrees. And I can see that that line goes straight across. Using our previous knowledge, how can I figure out what that angle is? What do we call these 2 angles? What vocab term did we learn? Chandrea? Ooh, this one's acute. We can see it looks cute and little. This one was big. So that one's obtuse. That doesn't help me with my angle measurement. What would help me with the angle measurement? Moses? Ooh, good thought. But corresponding angles has to have 2 parallel lines. This is only 1 line. So I can't use corresponding angles. Jackson? What does supplementary angles mean, Jackson? Who can help Jackson out? What are supplementary angles? Vinny? 2 angles that make the sum of 180. So if I know that straight angle line is 180 degrees, and I know one angle is 40 degrees, what's my missing angle? Michael? 180 minus 140. 180 minus my 140, I get 40 degrees. Now look, I have 2 angles of a triangle. Can I easily find my missing angle? Yeah. Okay, so some of these you have to use previous knowledge on. they're not all gonna be easy peasy, here's two angles, find the missing third angle. Oh, wouldn't it be nice if it was that easy? But Mr. Schultz really wants us to show that we can use other knowledge that we've already learned to solve these. Because they are not gonna all be easy peasy. How do you guys feel about that? I feel a little shaky. Maybe. You're going to want to look back at previous objectives. You look at this one, and I see two angles outside of the triangle, but I need to find all the angles that are inside the triangle. What am I going to use to solve that? What important vocab word did we just talk about, Michael? Supplementary angles, right? If we know the outside plus the inside equals a straight line of 180 degrees, and we know one of them, we can find the other one. Same thing with this one. We know the outside's 105 degrees. Add it together with the inside to get 180, we can solve for that angle. Then we have two angles of our triangle, and we can find our missing third angle. Did you have a question, Jack?
No.
You sure?
Yeah.
So we have to use that information that we know. Sometimes it might be vertical angles or corresponding angles. On this page, it's supplementary angles that we need to rely on. And then on the bottom, when it says draw and label, make sure you put those degree measurements. You need to label. On the test, I always have at least one person who forgets to label. Don't lose out on those easy points because you forget to label. Remember, if you're labeling, to follow the rules. If they're supplementary angles, they equal 180. If it's a triangle, they equal 180. Think about those acute angle measurements and the obtuse angle measurements. Make sure you're following all those rules. Look back at previous objectives if you need to. Do we have any questions on how to do this page? So you're going to do those ones on the front side, and you're going to do these ones. I walked us through how to solve these. Now you need to solve them. Okay? If you have questions, you're going to come see me. If you finish, you're going to work on that math packet. I'm going to see if we have time to make the packet video, because the packet is due the end of next week. So while you're working, I might work on the packet video a little bit. I'm going to give us a little bit of time to work and come to me with any questions, and then I'll work on that packet video. So make sure you're working on the packet and turning it in so you can make corrections. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.